In this recording, we're going to set the stage for solving linear systems by a technique called linear combinations. And you're going to see that known by other names, addition, or also elimination. I kind of like the name elimination because we're eliminating a variable by doing some algebraic manipulation. So today's lesson is just going to kind of set the stage for how we can use some of that algebraic manipulation and why it works. So let's consider this system here. We've done this a lot where we check to see if a particular point is a solution to a system. So can you go ahead and do that, please? Play the recording when you're ready. Okay, so hopefully it took time to do that. This first equation here I'll try the second equation. Okay, so it looks like it does check out. Now I want to find the sum of these two equations. Well, that's kind of a weird thing to do, you might say. That has some advantages, as we'll later see. So let's add up these two equations. Now it helps, in fact it's the only way to do it, when we add these if all the like terms are aligned. In other words, you get your x's lined up, your y terms, your equal signs, and then your constants. Now we just add the like terms. Those add to 0. And now it asks, is 4, 0 a solution to this new equation, this simple equation, 6x equals 4, is 24. Let's check it. So I'm substituting a 4 in place of x. There's no place to substitute my y equals 0. So yes, 24 does equal 24. This also checks in the new manipulated equation that we've created. All right, so now the next part says, look at this equation we found in part B. This equation right here, identify it. That's the one we created by adding the two equations. What happens? How does it allow us to solve for the variable x? What I might say is something like, the y variable is eliminated. Okay, so when there's no y's, it's just a simple equation with x. We can solve for x. All right, and how would we do so? Well, it's 6 times a number we don't know. We just undo that multiplication with division. So therefore x equals 4. It says, okay, now that you know the value of x, how can you find y? Well, we can do a substitution, right? So I can go back to either equation that has x's and y's. So either of my original ones. I don't know, they both look about the same difficulty. Maybe I'll stay away from the negative signs. I'll just do the top one because it has positives. That's usually sort of how my head works on those questions. All right, so we'll take that top equation. But now we do know the value of x. There's a kind of a weird case here where we subtract 16 from both sides and we're left with 3y equals 0. So it's like, well, what do I do with that? Well, when we divide by 3 on both sides to isolate the y, again, that divides to 1, we get y equals, well, 0 divided by 3. That's 0. So there's our y value. So our solution is 4, 0. right, so now that I kind of walked you through the first example, examples 2 and 3 on the following pages are very similar, but they add elements. In other words, we're basically walking you through how we're going to do some algebraic manipulations, of these equations in order to eliminate a variable. So I'd like you to try to work at your own pace on examples 2 and 3, and just play the recording if you want to check your work or if you get stuck at any point and you need help. So hopefully you pause to work these out. I'm going to kind of play these in fast forward because I'm expecting that you can do this substitution. You can kind of follow along with these prompts as we're trying to discover these techniques. Okay, so this we obviously showed that 1, 5 checks. Now it's saying multiply both sides of the second equation by 2 to get an equivalent equation. I'm going to check. And yes, it still checks. So multiplying both sides of the equation is not a problem. It keeps us still with a solution to that system that's the same. All right. It says, okay, now find a sum of the two equations. That refers to this equation and the original. So going back to our original equation, 4x plus 2y equals 14. That's our original equation. And now I'm going to take the manipulated form of that second equation, okay, the one we multiplied by 2 to get. I realize this should have been an 8. Let me fix that. Sorry. Okay, so I showed that I can multiply by 2. I can now add the two equations, and it still checks. 1, 5 still checks. So now I'm going to solve that equation for x. 6x equals 6. That's an easy solve, right? X has got to be a 1. How to find the value of y? Pick either of your equations. Might go with the top one again to avoid negatives, but the bottom one looks pretty easy too. You can go either way. So I went with the top equation, made those substitutions. And so our solution is 1, 5. Okay, the final example we're going to look at raises the bar even further. So see if you can go through this almost like a science lab, making the discovery, and play the recording when you want to check your answers or need help. Okay, there's two instructions here. Multiply both sides of the first equation by 2, and then multiply the second equation by 3. Let's try that. I'll do it with colors. Blue first. And along the way, see if you can figure out why we're doing this, why we're multiplying both sides by 2 in the first equation, and then by 3 in the second equation. All right, so we've seen that it works. I mean, it's reasonable to multiply the first equation by 2 and the second equation by 3, but you might be saying, why would I do that? Or how would I know to do that? And what I want you to do is look very carefully at what results when I line these two equations up to add them. So let's take my blue equation and my red equation. Use those same colors. That's my blue equation that I've created by multiplying both sides by 2. And my second equation that I've created by multiplying both sides by 3. Line up all my like terms nicely. All right, and look carefully at that. What is good about this setup? And hopefully it's jumping off the page at you. Like, these are opposite. When I add, the 6y's are opposites. Those add to 0. So I'm just left with an equation that has x's. Okay, so come back and say, how could I have known that from the get-go, that I might try to multiply the top equation by 2 and the bottom equation by 3? So think about that for a second, and play the recording when you're ready. So hopefully you had a chance to think about that. Well, I'm looking at these opposite, I've got a negative and a positive, but they don't add to 0. So I got to think about what I could multiply -3 by to get something that 2 also goes into. I'm thinking, this could turn into a -6 and this into a +6 pretty easily. You might have said, couldn't I have also done something with the x's, get them to be something that 4 and 3 both go into? Well, yeah, most definitely. Okay, so there's multiple ways to go about this. All right, and is this a solution to the equation? Yeah, we can figure that out by doing our little check over here. Okay, so at this point, I think we've seen this before. We've answered this question several times. The y's are eliminated, so we can now solve for x. And we've done that a bunch of times, so I'm not even going to write the answer. We can solve this by dividing, and lo and behold, it works out to be 3. Now how do we find out y? Well, hopefully you're like, hey, I've done this before. I come back up top, I grab one of these equations, whichever one looks easier to me. And I've been steering you towards smaller numbers and plus signs, right? Bottom equation has those. So let's stick with that. Let's use the one with smaller numbers and plus signs, although if you want to do the other one, you certainly may. All right, so I've got my two values of x and of y, and when I write them, I want to make sure I write the x first, so my solution would be 3, -1. So we introduced several techniques there for trying to eliminate one of the variables, the x or the y, so we could solve a nice easy equation like this to get one of the variables, and then it's going to be pretty easy once we've got one of the variables solved to solve for the other. Thanks for watching.